Moving on to example 3. In example 3, they want us to graph the given sequence. And the sequence that they give us is obviously not given to us directly, but they are telling us that they know that our third term is 3, and our third term, which is a sub 3, is equal to negative 18, and our common ratio is 3. So if we look at this, there's a couple ways that we can go about doing this. Obviously, since it's my third term, I can space this out and find it by just drawing it out. I could do that up here. My third term, so this is a sub 1, a sub 2, a sub 3. If I want to find my rule, I know I need to plug in a sub n is equal to a sub 1 times r to the n minus 1. So in order to find my rule, I have to know what a sub 1 is. I know my third term is negative 18, and if my ratio is 3, I know that I'm increasing each time by 3, which means if I go backwards, I'm going to be dividing by 3. So if I take negative 18 and divide it by 3, what do you get? Negative 6 divided by 3 again. Get negative 2, so I know my first term is negative 2. So if I plug that in here, I would be able to get my rule relatively quick. If I was given, let's say, the 16th term, this would be a lot more tedious to do. So there's another way I can go about using my original formula, just like I did with the arithmetic, to find my first term. A sub 3 is obviously n is 3. 18 is my a sub n when n is 3. So I can actually use my rule here. Negative 18 is equal to my first term, which I don't know yet if I pretend I didn't find it over here, times r, which is 3 to the, because my r over here is 3, 3 minus 1, 3 minus 1. If I break this down, I get negative 18 is equal to my first term, times 3. 3 minus 1 is 2. 3 squared is 9. To find a sub 1, I divide both sides by 9, so I still get a sub 1 is equal to negative 2. So depending on what you're given, you can work yourself backwards if that makes more sense. If you're given a much bigger number at the very beginning, you may want to use your original rule for the geometric sequence to help find that first term. Now that I know what my first term is, I can go back to the letter A and write my generic rule. And my generic rule is plugging it right into my generic formula. So a sub n is equal to my first term, which is negative 2, times 3, which is my r, raised to the n minus 1. And that stays as my general rule. I can't multiply these two to get negative 6 because 3 is the only value getting raised to the power. To go about and graph my sequence now, I already know my first term is negative 2, and I know I just keep multiplying each value of my pattern by 3 to get the next one. So I know my second term is negative 6, my third term was given to me negative 18. Keep going, times 3 gives me negative 54, times by 3 again gives me negative 162. And if I go through and I plot these are my inputs, my n, my outputs are my y, or my a sub n. I can write these as ordered pairs, just like that. I can plot my values over here on my graph. If I do that one, and if you notice, my graph, so this is first term, since the second notch is negative 40, I know that this is negative 20, so each notch is going down by a negative number. So this would be negative 60, negative 80, negative 100, negative 120, negative 140, negative 160, negative 180. And these are this is 4, so this is 1, 2, 3, 4, and 5. So my first point is 1, negative 2. Well, 1, negative 2 is going to be really close to the x-axis. 2, negative 6 is going to still be close to it. 3, negative 18 is going to be closer to the negative 20. 4 jumps to negative 54, which will be a little bit closer to the negative 60. And 5 obviously jumps to negative 162, which will be way down here. Again, just like my previous graphs, I'm not going to connect them with a solid line, but if you did, what you would be getting here looks like an upside down exponential function, which makes sense because my rule is an exponential equation in of itself. So they should be matching up. So you should be getting not a linear line just like you did for your arithmetic, but you should be getting something to the either positive exponential or negative exponential where it flips over your x-axis if you were to connect these two, all these points together. At this point, I'm going to take a little bit of time and work on now you tries numbers 4 through 7, and we'll meet back up in the next video to talk about geometric series.